Hello class, I'm working out of your Algebra 2 book 6.7 Polynomial Equations. I encourage you to go through the pre-reading after watching this video and look at the examples that are in that pre-reading to also help you. To get started, I'm actually going to work equations that are in the practice. So we will start with number 1 through number 4. That is work or explain. There are 3 ideas that you can find for number 1 through number 4, and you are looking for the answers of a root, a factor, or a 0. If you're given 1, you are generally looking for the other 2. In the next section for number 3, if you're given that negative square root of 7 is a root, p of x equals 0, then negative square root of 7 is also a 0 of p of x. And remember, the factor is opposite because we had set it equal to 0 to find the 0 or the root. So x plus square root of 7 is a factor of p of x. All right, we have root theorems on page 268. Before we go through examples, if we have a root that is 4 minus I, then you need to go out and grab that 4 plus I is also a root. If 6 plus square root of 7 is a root, so is 6 minus square root of 7. So you may find or solve for only one of those. You need to think about the conjugate root theorems and go out and grab the other root that is part of the equation from those theorems. Look those over. On number 20 in the actual practice, you're asked to solve each equation using the rational root theorem to identify possible roots. You're given an expression that looks like this. Remember that we're going to first note descending order. So if we put that in a form of a polynomial in descending order, that'll be on one side of the equal sign, equal to 0. So we're going to pick up our highest degree term, that's x cubed. We see now we have a 2x squared. That's minus 2x squared. We're going to add 2x squared to both sides. So it'll be 2x squared on the other side of the equal sign. We've addressed these two. We have a linear term. The x term is just negative 5x on the same side of the equal sign that we're isolating everything. And then we have a positive 6. We're going to subtract 6 from both sides, and that'll set this expression equal to 0. This is the expression we'll be working with. So we're going to consider our P's and Q's. Remember that those will be positive and negative. So P equals 6. Even though it's a negative 6, we'll consider that shortly. We have the factors of 1, 6, 2, 3. And Q equals 1. That's the coefficient on the x cubed term, the highest degree term. And P over Q now becomes positive and negative 1, positive and negative 2, positive and negative 3, positive and negative 6. Because everything has a 1 in the denominator. Now these are our possible zeros. So we have 8 of them in the positive and negative. We start trial and erroring it, and we pick to solve. So we can generally start picking from the 1. That's the easiest one to plug in or substitute to our polynomial. So we plug in a positive 1. I'm going to rewrite this at the top so we can work with it. We're going to say a positive 1, that's going to be cubed plus 2 times 1 minus 6 equals 0. I substituted in a positive 1 everywhere we see the x variable in our polynomial. Now let's see what we get. 1 to the third power is 1, plus 1 to the second power is 1. 2 times that 1 is still 2. Then we have negative 5 for the next term, minus 6 in the constant. Is that equal to 0? One plus 2 is 3, minus 5 is negative 2, minus 6 is a negative 8. It's not equal to 0. So we do not have a root that will work when this is not equal to 0 or a 0. Okay, remember root and 0 match in terms in section 1 through 4, the first section 1 through 4. So we do not find that 1 substituted into our polynomial will throw a possible root. So let's try something else. We've got to try another one. We're going to try negative 1. That'll be to the third power, working underneath here, plus 2 negative 1 squared minus 5 times negative 1 minus 6. Alright, let's carefully work this. And we're going to get negative 1 to the third power is a negative 1. Negative 2 to the second power is a positive 1. Positive 1 times 2 is plus 2. Okay, now we have minus 5 times negative 1. That is minus a negative 5. Look that over. This sticks, and then work with 5 times negative 1. Put that in parentheses. minus 6 equals 0. What do we get? Let's address everything. Negative 1 plus 2 is 1. Plus 5 is 6. Minus 6, 0 equals 0. So we are testing negative 1. That means negative 1 is a root. So x plus 1 is a factor as we're working. So now we use synthetic division with negative 1 as a 0 to decompress our polynomial. So if we go back, we're going to pull a 1, a 2, a negative 5, and a negative 6 to set up our synthetic division. And use our 0, negative 1. Remember, this comes down to start. All right. Negative 1 times 1 is negative 1. 2 plus negative 1 is 1. Negative 1 times 1 is negative 1. Negative 5 plus negative 1 is a negative 6. Negative 1 times negative 6 is a positive 6. Negative 6 plus 6 is a 0 remainder. Because we started with our x cubed term in the original polynomial, we're decompressing in synthetic division, and we will rewrite our new polynomial as x squared plus x minus 6 is equal to 0. Okay, so if that's true, then this is one of the factors of our original polynomial. But remember, we're working from this division. So if that is true, then x plus 1 is also one of the factors of our polynomial. Go back and grab what you divided by as a factor. We decompress the polynomial here. This still is hanging out here from working with it. Okay, so factor the larger polynomial, the trinomial here. Let's say we're going to set out our x's, and we need a negative 2 and positive 3 to get back to negative 6 in the constant, but have an x term in the middle. That is just a coefficient of an invisible 1. We still have x plus 1 in the front, and now you can find our solutions of x. X is going to be equal to negative 1, positive 2, and negative 3. Those are our zeros for that polynomial. Let's go back through just to look at everything we did. We made sure our original expression was in descending order. We considered our p and q terms. P over q is a positive and negative possibility for each factor. We started testing our factors for zeros. We found that negative 1 has a 0 remainder. We used that polynomial to work synthetic division to find the other solutions for our x. When we got a decompressed polynomial, we remembered that our negative 1 was one of the factors in our decompressed polynomial that has to be multiplied by. So we go up there and we say, okay, well that's x plus 1 equals 0. That's a factor of this polynomial. So we included it here with our decompressed polynomial. We factored our decompressed polynomial from synthetic division, and that throws all our zeros that the x is equal to in solution. All right, if you are given the zeros like in number 28, and you are just given -1, -3, and 3/4, then in much the same way of what we just solved, you're going to say, well, this is x plus 1 for a factor, and then this is x plus 3 for a factor, and then this is x minus 3/4 for a factor, but work with it set equal to 0, so you can get rid of that fraction, and you're going to have 4x minus 3. And then you're finding p of x. I won't work this out in the video, but you continue to solve for the polynomial expression from these three factors. Okay, once again, go through the pre-reading examples, look those over, consider that when you factor your polynomials, you may need to use the quadratic formula, you may need to consider imaginary numbers, you need to remember your conjugate root theorem, that if you have one root, that the conjugate is also a root. All right, go back over those in the reading, and we may need to factor by taking roots on both sides of the equal sign and so on. All of the things that we've used up till now in factoring could be considered in these chapters as well, because we're still factoring polynomials as we're solving for roots. I hope this helps, and I'll see you soon.